All right, here we go. This is lightning talk number 6. This is Kory Draughn from iRODS Consortium. More transport, please. Take it away.
Thank you. Yeah, so I'm just going to talk about the transport since I know everybody loves to hear about it. So here is the interface. I've stripped down everything so that you can see exactly what what it means to implement. So you have lots of ways to open a transport as well as close it and send and receive, seek, and then querying information about the transport. This class does not is not responsible for trying to verify if its state as far as like when a close should happen is correct. It's more on this is just a way to bundle a bunch of functionality together as far as shipping bytes across the wire. The responsibility of making sure these things are called appropriately is on the DStream, and hopefully if you implement this properly, you won't ever have to worry about things going wrong. So why is this interesting? Is because it enables us to do wizardly things. And this is not just us, but for anyone who wants to use it. Some examples here is we can achieve compression, encryption, doing things like recording statistics and diagnostics, as well as implement new protocol support for things such as RDMA. We actually have an implementation of UDT available that was done probably almost a year ago, but we're just kind of sitting on top of and not sure what to do with it just yet. But hopefully there's more things we can get out of this. So just to give you an idea, like this is one I've been working on, like introducing Google's snappy on compression support in the iRODS. And this is, I've stripped out everything here so you can just see what the main things were that was needed to make this go. Basically, this snappy transport just takes in a native iRODS transport object, and it just essentially compresses and decompresses data depending on whether that data was, I guess, depending on the situation. So you can see here's just a couple lines. Hopefully that's not scary to everyone. And here we can see how it might be used within like a client. So in this top case, we have, let's say we read a whole lot of data into a large buffer, and we instantiate the default iRODS transport, and then we open up an object, and if we open it successfully, we can write all that data to it. This is essentially what iStream does. But how about if we wanted to enable compression? Well, if we wanted to do that, all we have to do is pretty much just wrap that existing default transport within another transport, in this case, snappy transport, and it's all the same to the DStream object. It just takes the transport and it just writes out that data and compresses and decompresses things as it needs to. So I've been doing some testing with this. Obviously, snappy it doesn't work just by itself, but by implementing a transport. For iRODS, we also want to have the server support compression and decompression as well. So I have a custom build of iRODS that has an implementation of snappy compression and decompression. And I ran a test using the traffic controller to emulate a 200 millisecond round trip time delay, and using a file of about 73 megabytes and a buffer size for the stream object of 4 megabytes, we were able to basically achieve an improvement, transfer times of 40% faster, and read speeds of about 36% faster than the default iRODS transport. And obviously, because this is compression, this is highly variable. The results are just variable because this also depends on your network, the file size, and the buffer size. Obviously, if we didn't have any delay and it's just done all locally, compression is actually slower or on par with the normal transport. So hopefully in the future, we'll be continuing this process and introducing more things and with this transport library that's provided by iRODS. That's it.
Thank you, Kory. I love seeing things go faster. Can you talk a little bit more about the other decorators that you mentioned earlier? You know, if snappy compression is just a decorator, I think the implications of this particular slide are huge. Can you take a minute or so and just talk about what this means? You've just packed a lot on this one slide.
Yeah, so actually, I think last night I actually implemented a statistics transport last night just to see if all of this was true. And I was able to actually, I guess you can say, properly track the times of just the transfers within iRODS. And so what that means is that this transport, just by simply having this tiny interface for iRODS, we can do, it opens us up to a lot of new things as far as moving bytes around. And it's not just about moving bytes, but also enabling the community to do the same things. Like maybe they can achieve the same, these schemes that we implement with iRODS are transferable to things like Python and things like that. So this is not a C++ specific thing. This is just, we just chose to do it in C++ because that's primarily what we use. But with Python, you can likely achieve the same things. You just have to, you know, implement the tools there.
That's right. Very good. I love it. Thank you, sir.
Mm-hmm.